Hi everyone, today we'll discuss about push-pull amplifiers. Today we'll discuss about push-pull amplifier or the question is like this. Push-pull amplifier, how push-pull amplifier eliminates harmonic distortion. How push-pull amplifier eliminates harmonic distortion. Normally in power amplifiers, because of non-linearity, there will be some distortion. That is called harmonic distortion. This will play major role in the power amplifiers. The power amplifiers are classified based on the Q point or operating point. If the Q point is changing from one place to another place, just like this is for example characteristics, this is the Q point. The Q point is on the active region, that is called linear region. But in power amplifiers, the Q point moves above the active region or below the active region, or it may move towards saturation region or towards cutoff region. Because of this movement of Q point towards saturation region or cutoff region, there will be some non-linearity. Because of that, there will be some noise or distortion in the power amplifiers. So this will play major role. That is why how it can be eliminates. That we'll discuss here. Push-pull amplifier is used to eliminate the harmonic distortion or even harmonics. How it eliminates even harmonics. We'll see now. This is the basic circuit diagram of push-pull amplifier. This is the input transformer, or it is called as a shunted tapped transformer, or it is also known as a phase splitter. So phase splitter, shunted tapped transformer. Here we are giving the input at the primary of the transformer, and it will give the shunted tapped output, equal output. Then R1 R2 provides the biasing. This is the supply VCC, and here we are using the two transistors, Q1 Q2, both are in NPN transistors. We are using two transistors, Q1 Q2, both are NPN transistors, and both emitters are connected together, and both collectors are connected to primary of the output transformer. This is output transformer. Here the output transformer primary is connecting to the two collectors, and the secondary of the output transformer, we are going to collect the output. Another important point is, at a transistor Q1 side, the current flowing is I1. At a transistor Q1 side, the current flowing is I1. At a transistor Q2 side, the current flowing is I2. Let us assume the output current is I. So this is the load resistance. It may be load, it may be loudspeaker, or whatever it may be. Then come to the operation. Q1, Q2 are NPN branches. Whenever we give the positive half cycle, during positive half cycle, Q1 is on, Q2 is off. So these two are alternatively on and off. During positive half cycle, Q1 on. During positive half cycle, Q1 on. Then it will give the output. Similarly, during negative half cycle, during positive half cycle, Q1 on, Q2 off. Output is like this. Similarly, during negative half cycle, Q2 is on, Q1 is off. Q1 is off. You'll get the output like this at the load resistance RL. This Q1 on, Q2 off. This alternative connection is nothing but push-pull operation. Q1 on, Q1, Q2 are alternatively on and off. This is called push-pull operation. Then if you see the mathematical expression of the push-pull amplifier, the output current I is proportional to the I1 minus I2. The output current I is proportional to the I1 minus I2. So I is equal to, I am taking one proportionality constant K into I1 minus I2. I is equal to K into I1 minus I2. Let us take this is the first equation. This is the major equation. Then I want to find I1, I2 individually. Then I will substitute here. Based on that, we will find final I. So at transistor Q1, what happened? The input current is IB1 is equal to IBM into cos omega t. So the input current I is equal to Im cos omega t, like that. So at consider Q1, that is what there is a IB1. At base 1 we are giving, this is the base 1 of the Q1. So IB1 is equal to IBM maximum peak into cos omega t. IBM into cos omega t. This is second equation. Then go to the output current. Output current I1 is equal to ICQ plus B0 plus B1 cos omega t plus B2 cos 2 omega t plus B3 cos 3 omega 3 omega t plus so on. That is the third equation. The output current is I1. Output current here in the Q1 transistor loop, the output current is I1. So I1 is equal to ICQ plus, here we have some harmonics. B0 is a constant plus B1 into cos omega t, first harmonic, B2 into cos 2 omega t, second harmonic, B3 into cos 3 omega t, third harmonic, plus so on. You may take n number of harmonics. That I am considering as third equation. Similarly, go to at a transistor Q2. At transistor Q2, the input current applying at base 2 is IB2. Then see here, this is the second transistor Q2. Here the input current is IB2. IB2. So same as that, IB2 is equal to IBM into cos omega t plus phi. Here we are getting the phase shift 180 degrees. That is why we are taking plus phi. So IB2 is equal to IBM into cos omega t plus phi. This is the fourth equation. Same as the second equation. Then go to the output current. Then output current I2 equal to, for the second loop or at transistor Q2, the output current I2 equal to same as third equation, ICQ plus B0 constant plus B1 into cos omega t plus phi plus B2 into cos 2 into omega t plus phi plus B3 into cos 3 into omega t plus phi plus so on. Here I am taking up to third harmonics. Then I am going to simplify this. I2 equal to ICQ as it is, B0 as it is, and B1 cos omega t plus phi. Omega t plus phi is nothing but minus cos t, minus cos omega t. So minus B1 cos omega t. So plus cos omega t plus phi is nothing but minus cos omega t. So minus B1 into cos omega t plus B2 cos 2 into omega t plus phi. Here we have 2. So that is a 2 pi 360 degrees. So cos t, cos omega t plus 0 or 360 is cos 2 omega t only. So that is a plus B2 into cos 2 omega t. Next plus B3 into cos 3 omega t plus phi. Cos 3 into omega t plus phi in minus cos omega 3t, minus cos 3 omega t. So that is B3 minus B3 into cos 3 omega t plus so on. Then this is a fifth equation. This is the fifth equation. So just omega t plus pi is nothing but minus cos omega t. And if we have even number, that is plus only. Then from fourth to fifth, sixth, seventh equations, then we are going to write I is equal to K into, same as this, I is equal to K into, we know I1, I2, I am substituting that, I is equal to K into, I1 I am writing, I1 is nothing but ICQ plus B0 plus B1 cos omega t plus B2 cos 2 omega t plus B3 cos 3 omega t plus so on, minus, this is I1, minus, I want to write I2, I2 is from fifth equation, ICQ plus B0 minus B1 cos omega t plus B2 cos 2 omega t minus B3 cos 3 omega t plus so on. Then again simplify that, I is equal to K into, same, ICQ plus B0 plus B1 cos omega t plus B2 cos 2 omega t plus B3 cos 3 omega t. See here, minus ICQ minus B0 minus into minus plus B1 cos omega t, B1 cos omega t plus into minus minus 2 B2 cos 2 omega t plus B3 cos 3 omega t. So here already here minus B3 we have, so minus into minus become plus. Then if you see that, so here we have plus ICQ, here we have minus ICQ, plus B0 minus B0. Similarly plus B2 cos 2 omega t minus B2 cos 2 omega t, all are cancelled. If you simplify once again, here we have B3 cos B1 cos omega t, B1 cos omega t, 2 B1 cos omega t plus B3 cos 3 omega t plus B3 cos 3 omega t, nothing but 2 B3 cos 3 omega t. So I am taking 2 common, 2 common, I equal to k into here 2 times B1 B3 came. So I am taking 2 common, 2k into B1 cos omega t plus B3 cos 3 omega t plus let us take some more harmonics like B5 cos 5 omega t. Then if you see this, here we have only odd harmonics B1, B3, B5 and so on. Here we have only odd numbers. So here there is no even number, nothing but even harmonics are eliminated. It eliminates even harmonics. So hence push-pull amplifier eliminates even harmonics. So push-pull amplifier eliminates even harmonics. Most important question, explain about the harmonic distortion in the power amplifiers, or explain how push-pull amplifier eliminates the harmonic distortion, or explain class B push-pull class A push-pull amplifier. This is the major topic, and here from this we may describe class B and class AB power amplifiers by making small modification in the circuit. This is very important, and we will see remaining amplifiers in the next class. Thank you.